Hello again. We are going to continue our discussion of object-oriented principles, focusing on more of the abstraction side of things by looking at virtual functions and abstract classes in these exercises. So starting off with the first exercise, we're going to make an abstract base class called GameEntity with pure virtual functions such as render, update, and load. And I guess I'll just do the three. If you feel like doing more of them, you are perfectly free to do so, but we're just going to keep it simple and do exactly what it says here. Now, notably, this doesn't mention anything but a main function or anything like that, so what I'm going to do is I'm actually just going to build a header file that's going to contain this abstract class, and I'm not going to make a main function just yet. I will use G++ to compile this with the -c flag, just to make sure I've coded it correctly, but I'm not actually going to do anything with it, because the whole point of an abstract class is that you can't make one. It is a concept that's we're going to need to implement later by inheriting from this game entity class. And this is kind of representative of how a lot of actual games work, which is that an entity in a game, maybe this is something like a character or a unit or something like that, maybe it has functionalities such as being rendered, being updated, that are common to any entity that's in the game, whether it's a unit, whether it's a person, whether it's an item, and so on. All of them, if they are game entities, need to be rendered so I can see them, need to be updated because something happened to them. And how these happen is going to obviously vary from thing to thing. But they all are going to have this capability in common with them. So what I want to do with this exercise is to make a base class, an abstract base class, where you can't just make a game entity. It has to actually be an item or a person or so on. But it will describe everything that needs to be true for something to be a game entity. So let's make a, we're going to do, again, we'll do this in folders because we want to be able to separate the files we're working with here. And right now I'm going to have my first one, and this is going to be a game entity.h. Okay. There we go. I don't know if I need to have the header guards, so I'm probably just going to leave it as it is. But I want to make my class. It's called game entity. I suppose I can make it a CPP file. I guess it's okay to do it that way. It's probably fine. And we'll just include the CPP files. It's all right. So my game entity class, I want to make this an abstract class. In some languages, and I think Python might be like this, I'm not sure off the top of my head, but in some languages, if you want to declare something as an abstract class, you would actually label it abstract. In C++, you don't. Instead, what you're looking for something to be an abstract class is for it to have virtual functions. And so it says here a virtual function. What's a virtual function? It's a function that doesn't actually have any behavior when you set it up in the base class. So here, I'm going to publicly have these functions render, update, and load. And now, normally I would give these a type. I guess I do have to give them a type. We'll just make them void, I suppose. But normally I would declare them perhaps and then define what their behavior is. What I'm actually going to do is I'm going to do something a little weird, and it's going to look like this. And what I'm doing here is I'm saying, and I also need to write the word virtual in front, that this is a virtual function. It's a function that needs to be implemented in any subclass of game entity. But a game entity itself, since I can't have one, doesn't need to have any implementation of it. So I just literally say this function is nothing. It doesn't exist just yet. I can do the same thing for these ones, equals 0, equals 0. And that's actually it. So now I have told my computer, okay, this is a game entity. It has functions render, update, and load. And if I later want to make a subclass of game entity, then it is going to need to implement these and not just have them be equal 0. They need to have actual behavior. But I'll get to that when that matters. For now, I just want to make sure this worked. Game entity. Yep, everything seems okay. So I can compile it, which means I'm done part 1. Now I can move on to part 2. Okay, part 2. Develop two classes, character and item, derived from the game entity class. Implement the virtual functions with functionality specific to characters and items respectively. Okay, so let's do that. We're going to copy example1 into a folder called example2. So I still have my same stuff from before. And let's make some new files. So I need to have a, what does it say, person? Is it, no, character and item. Okay. So character.cpp and item.cpp. Both of these are going to be game entities. So just planning ahead, I know I'm going to need to include this a couple times. So I will not put the guards in just yet, just so we can see the error when it does come up. But I'm keeping in mind that I will have an error if I don't put those guards in later. So for now, I'll just leave it and it's fine. But my character CPP is going to include GameEntity.cpp. And it'll be a class character which inherits from GameEntity. And so this means that all characters are game entities, but it also means that I need to implement those three functions from before, which were the following: render, update, and load. And now I can't, instead of making them virtual, I'm going to actually implement all of these. And I'm going to say, okay, here is my render code. Character on screen, for example. I'm not going to have some actual rendering here because I don't think we really have the time for that, but just so you can kind of see what the main point of these are, we'll just put some messages out so we know things worked. Character updated. And over here, character loaded. And then our item will be basically the same, except we'll say item on screen, item updated, item loaded. Now when I compile this, or I should say when I try to compile item, I suppose I can try to do them one at a time. So if I do compile item.cpp, oh, what is it unhappy with? Oh, so I think it's looking for IO stream because I'm trying to print stuff. So let's put that in there. And we'll do the same thing over here. Okay, and I can compile character.cpp. But something to keep in mind is if I tried to do them both at the same time, oh, I guess it seems okay with it. We'll see if we'll see how it feels if I make a main function. Maybe I'll do that now just so I can kind of see how this all is gonna like fit together. Sure. So we'll make a main.cpp. This is going to include IOStream, include character, and item. And so we'll make these things. Character C, item I dot load, C dot update, just so we can actually see this work, right? And now if I compile main, let's see here. Yeah, so now I have the issue of redefinition of class game entity because when I try to compile my main, it tries to include both of these CPP files, and each of these is trying to include my game entity. But that means I'm declaring this thing twice, which is no good. So I'm going to say if not defined game entity, define game entity, and if. Just so I don't get that error. Clear, compile. Okay, now what are we unhappy about? Cannot declare variable C to be of abstract type character, but character is not abstract. At least it shouldn't be. Maybe I'm missing something. Oh, I think I know what I'm missing, which is I need to specify that I'm actually trying to override the these virtual functions. They're not virtual, they actually are some real stuff. And I'm guessing the same thing happens with here, yeah, abstract type in, but these aren't actually supposed to be abstract. I want to specify that, and what I'll do is I'm going to say override on all of these. Override, 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 and hopefully that should help. Oops, still unhappy about this. Marked override but does not override. I think, let me see here. Oh, I think it might be I need to put the constant in as well. Constant override. Constant override. Okay, there we go. Always important that you match all of the different parts of your function so it actually is doing the overriding. But so what do I write in here? The override key specifier, it's not actually a keyword, is here to tell C++ that I'm not just writing my own render function that's also a virtual one. It's trying to implement, to override the abstract function render that I made in my GameEntity class. This is a virtual function. You don't have to make it a constant function to give you a constant value. It's okay if it doesn't. But just so you can see that this is important to include if you're going to include it somewhere. Because you'll notice it worked okay with update and load to not have this written here. So it's not written here in either one. Which is why I need to make sure that I match it over in this spot. So now that I have overridden these three functions, I now have implementations of them in my characters and items, which means I can actually compile my code and run it. Hooray, and it says the item loaded and the character updated. Great. Okay, I think it's good for this exercise. Let's move on and see what else we can do. Okay, so exercise 3, extend your hierarchy with some more specific derived classes such as player and enemy from character and weapon and potion from item, each with overridden virtual functions with their unique implementations. Okay, so it's kind of more of what we're doing, except that we're just going another tier, another level down. Just like before, I'm going to copy my directory into example 3. I'm going to close everything. I'm going to open example 3. Okay. So right now I have my characters and items, and I want to override, or I want to have subclasses of each of these. And it said player and enemy, I think, was it? Player and enemy, weapon and potion. Sure. So now, let's do player and enemy first. So here is character. I'm going to make a duplicate of it. And this is going to be the one for the player. The player is going to need to include character. It's a type of character. That's player, player, player. Oh, I edited all the wrong code. I'm supposed to edit this code. There we go. So a player is a kind of character. Just like a character, it has these three functions, except I'm overriding them to be different now. I'm going to duplicate this as well, except this time I'm going to make this an enemy. And the same thing, enemy, 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 enemy. And then similarly for the item, I'm going to duplicate this. And we're going to have a potion. So a potion is a type of item. Potion, potion, potion. And we'll duplicate this to make weapon, which is also an item. Weapon, weapon, weapon. Okay, so lots of CGV files now. Let's first of all make sure that I can compile everything. Okay, so everything compiles okay, so I don't have any like blatant errors clearly. Now, what I want to do is I want to make sure all this works. So in my main function, I'm going to have to include these things I want to make. So we'll do a character, an item, and I suppose we can do all of the other things we just made as well. So we had player, enemy, potion, weapon, and let's make all of these. So just gonna shortcut my way through of typing this. Save myself some typing time. These are not .cpp's, these are the types. PL, enemy E, potion PO, weapon W. And I'll make sure that I can call a method from each one. So pl.render, e.load, po.update, w.render. Just to make sure that I can do all of the things. Now I'll compile main. I think it'll have an error because I am redefining characters and items because these don't have their include guards. So I got to put those in. Now I have an include guard here, so I'm going to steal it. Yank. So character will have an include guard for character. An item. Oh, I didn't copy the include guard. Will have its own include guard as well. Okay. Let's try that again. Compile. Everything is good. Run it. I got my items, I got my characters, players, enemies, potions, and weapons. All good to go. All right, let's move on. Okay. Create a game loop that has a list of game entity pointers, and in each iteration calls the update and render methods on each entity, demonstrating polymorphism. What is polymorphism? It's basically this principle that because all of the things I made are game entities, every single one of them, whether they're characters or items or enemies or so on, they're all game entities at the end of the day, which means all of them can be updated, all of them can be rendered, and all of them can go into a, this is a list, but let's be real, this should be a vector. Okay. So, let's do that by closing everything first, copying recursively all the files from exercise 3 into exercise 4. I'm going to go over there. Okay, and here we're going to definitely need vector. Vector. I'm going to save myself some headaches. I'm going to use namespace std. Okay, so I made all of these items. Made all of these game entities, I should say. Now, I don't know if I can make an array of game entities. It's possible. So let's say that I have game entity entities equals new game entity. Let's say or no, this is a vector, right? It's a vector of game entity pointers entities, and then I can do entities push back each of these different things. I, PL, E, PO, W. First, let's make sure I can do this, and I haven't made a blunder, which I may have, but we'll see. Compile this. Oops. CD exercise 4. Compile this. Okay, it's very mad. Let's see here. Why are you angry? Character ampersand. Why does it think it's a character address? Oh, that's why. It's because I am trying to push each of these types of things in here when I should be pushing in their addresses, I believe. Let's see if that fixes it. Okay, there we go. Always important to know your pointers, right? So this is an array of a vector of pointers, because I don't want to be putting the entire data into this vector. I just want it to reference all my different entities that I have. I don't need to include game entity, and in fact, I probably can get away without including character or item. Let me see if that's true. Yeah, I don't need to declare a character or item either, because they're already included in player, enemy, potion, and weapon. So I don't need to include them. They're already included. Okay, now, I got my vector. It's got all of my things in it, and now I want to loop. So we'll do while true, very excitingly. And we'll say type exit to quit. We'll get a string variable input, C into their input, if input is exit, and break. Otherwise, we're going to, for each game entity pointer in GE inside of entities, we will do GE arrow what did it say? Update and render? Yeah, sure. Update GE arrow render. Remember, GE is a game entity pointer, and it's going to point to each of my different things that I made. Now let's see if this goes. Oh, I missed a semicolon. I put a colon instead. Okay, seems to compile. Great, so when I send it in, notice that it updated and put on screen all of my different things by calling each of their respective versions of update and render. We saw with the last set of exercises with the art examples that when we wanted to call a method that belonged to the base class, in that scenario the base class I think was called art. This time our base class is game entity, but game entity is not just a base class, it's an abstract base class, which means C++ understands that when I am trying to figure out whether I'm going to update or render, I'm going to do something that's called dynamic binding. And what this means is that the computer doesn't bother to figure out which version of update or render I'm dealing with until I've actually gotten into this part of the execution of the program. And at that point it says, okay, we're trying to update this game entity pointer with this game entity pointer. Now, what method is update? We've done like 6 update methods, maybe even more. I think we did 6. Not including the virtual one. And so to figure out which one it is, it goes to the pointer and says, hey, what kind of game entity are you? The first one is a character. So it says, okay, well, then do this update that says character updated, and then this render, character on screen. And that's exactly what we see show up here. And it does the exact same thing for every other part. And so the polymorphism part of this is that I was able to write a single loop that says for each game entity, update it and render it, without me having to say, if it's a character, do that update. If it's an item, do that update. If it's a player, do that update. I just can go through and I can use the exact same interface to access all of their respective versions of those different methods. And so that's the whole point of this exercise. All right, and now we can move on from this. Okay. Exercise 5, implement virtual methods for interaction between game entities, such as a collide with method that takes a game entity, behaving differently depending on the types of entities interacting. Okay, so this sounds like a lot of stuff, but it's actually not too bad once we start working on it. Just like before, oh yeah, exit to quit, please. Copy exercise 4 into exercise 5. Okay, and we're going to implement this in the game entity file because first of all, we need to have this method, collide with game entity. Virtual, this is also, I suppose, we can make it a void function as well. Again, you could do other stuff, but, and this is 0 because this is a virtual function. Okay, so a game entity can collide with another one. And so what we're going to do with this is we're going to implement this differently for characters versus for items. And then we'll see what happens when we collide some of these together. So for a character, copy all this. So this is going to be collide with. It's going to take a game entity, GE. I suppose we can make this so that it works differently based on whether a character collides with a character or a character collides with an item. So we'll say collides with. Do I want it to work that way? Let me think. I suppose what I'll do is I'll implement I'll override the game and this collide with function, GE, override. And what we'll do is we'll make it so that when a character collides with a game entity, then we will say, we'll do something like this. Printf, character collided with, and then we'll render the game entity and print a new line. And so this way, we know that a character collided with something. We'll render the other character, meaning we'll print out, character on screen, for example. But if it's not a character on screen, it'll say character collided with item on screen, or whatever it is. We're going to just render whatever that thing is that it collided with. And that will be it. And I suppose we can do the similar thing for item. Yeah. I'll say item collided with blank and render that. And then in our main function, before we start doing all of the stuff, how about we have two things collide? So we'll say PL dot collide with, yeah. Collide with, let's say the player collided with a weapon for fun, and an enemy collided with a potion. Sure, why not? Or how about a potion collided with the enemy? And let's see what happens. Okay, what did I mess up? Cannot convert weapon to game entity star. Right, because I'm supposed to be passing it pointers. Yeah. Try that again. Okay, clear, go. Now it says character collided with weapon on screen, item collided with enemy on screen. You notice it says character and item, and it doesn't say player and potion, because if I wanted it to, I would need to also implement those methods. I would need to override those methods again inside of player and potion. So maybe you want to, maybe you don't. Totally depends on what you're doing. But in this case, I at the very least have a collision function where it's going to call various methods, various different versions of the render method depending on the thing that I'm actually crashing into. And so this can be very useful if, for instance, you want some graphic to play or some other kind of thing, and you don't want to have to make 50 million collide with functions. You just want to make one of them and say, anytime I crash into anything, do this. And all you need to make sure is that when you are colliding with a game entity, if you want this to happen regardless of what you've collided with, you need to make sure any methods that are being called here are ones that belong to game entity and aren't specific to some other thing. If characters colliding with an item, for instance, shouldn't cause anything to happen, maybe you actually want it to be the case that this collide with only matters when they collide with a character, for example. But it's totally up to you. It depends on exactly what you're making. There's lots of, obviously, versatility because of this mechanic that you can use. All right, let's move on. Okay, exercise 6, and this is a bit of a doozy, so bear with me for a bit. Implement an abstract observer class, then implement an abstract subject class and make your player class inherit from it. So probably what we're going to do is we're going to make a subject, a kind of game entity, and we'll make a player a kind of subject. So it will also have all of the same properties of game entity and of subject. Whenever a player's state changes, notify all observers. So before I go any further, let's talk about what these ideas are of observers and subjects and so on. And what we're getting into here is actually this concept called design patterns. And it's really about how programmatically there are certain ways that you might want to represent how a game, for instance, or more specifically, events and consequences should actually happen in the context of computer programming. So the idea behind an observer is a kind of design pattern, is that you might have some kind of concrete object, say a player, and something happens to the player. And when something happens to a player, sometimes you might want other parts of your system to respond to that, to do something about it. So because the player is the thing where we care about what's happening to it, we call it a subject. It's something that's being observed by some other part of your system. And the parts that are observing it are called the observers. This could be something like, if you think of, for instance, in like the video game concept, maybe a player loses some health because something happened to them. You might want your chat window to say, oh no, player lost 5 health. But how would you know to print that message in there? Well, what you need is you need to have some code that's been implemented so that any time that the player's, for instance, health changes, or in this case, we call that just state, the properties of the player have changed in some form, we do what's called a notification. We notify anything that's observing to behave in response to what's happened here. And now the notification that we're going to do for here is going to be very simple. We're going to make a concrete game observer class. This is going to inherit from the general observer. And the game observer thing is just going to print a message. So when the player says, hey, I have done a thing, the game observer will print it out. Not too much is going on with that. What's more significant here is really this relationship between observers and subjects and how they inform each other. So exercise 6 includes all this stuff. Use it, please. Copy exercise 5 to exercise 6. Okay. So what we're going to do is we're going to make a player include, actually what we'll do is we'll make a character inherit from subject instead. Yeah, I think that's okay. So here's what we'll do is we're going to make a, I guess we can duplicate character, sure. And we're going to make this a subject.cpp. A subject is a kind of game entity. It's going to be, it's going to need its own thing here. So a subject is a kind of game entity. And a subject is going to be an abstract class, which means I'm not actually going to override any of these. Oop. Nope, not that either. The only method that my subject is going to have, or actually it's going to have a few things. So a subject, because it is being observed by things, is actually going to need to have a couple things here. So first of all, I need to include vector because, and we'll use namespace std. Yeah. When things happen to my subject, I want to inform all the observers. So each subject is going to have a vector of observers. And I guess before I can actually even finish subject, I need to make that observer abstract class. Now, probably what we'll do is we'll say that a game entity is not, an observer is not necessarily a game entity. It could be, but in this case, we're going to say it doesn't have to be. So we're going to make a brand new file called observer.cpp. Now, observer is actually not going to be too complicated. So our observer class is called observer. Ooh. And our observer class is just going to have a virtual void notify. And it's going to take a, and I guess I need to include IOStream. It's going to take a string message and that's it. And so this function here will be implemented by our game observer. Our game observer, which I guess we can do next, why not? Duplicate this is game observer. So our game observer is going to be a kind of observer where when it takes the message, it's going to print, or I guess what we have to do is see out, right? Game observer notified of message. Yeah, so basically what's going to happen now is, now that we have game observers, our subject can have a vector of observers, and we're going to need to include that. Observers. We're going to have a vector of those. Probably I could take them by the pointer. I don't need to actually have the object itself, and we'll call these the observers. And what we'll do is we'll have methods to add them, and we'll have methods to notify them. So first will be void add observer, given an observer O. And we'll do observers dot push back the address of O. Not too fancy. And then void notify observers for each observer pointer O inside of my observers vector I want to notify. And we'll notify them with, I guess we need a message to give them. So let's, string message, we'll give them a message. Okay, so we'll compile these three to make sure I haven't done anything silly, but there's more to do. Is my subject okay? No, what did I mess up? Cannot declare parameter O to be of abstract type observer. Okay, so it's not particularly happy about that. Which function is this in? An add observer. Oh, I should take a pointer. That's what I should do. We'll take a pointer to an observer. There we go. Okay. And this is unhappy because I'm trying to say that I've constructed an observer, but you can't construct an observer. It's an abstract type. Observer and subject. I suppose my subject is like not super abstract, but it's okay. I'm not actually going to make a subject anyway. But my player now, or sorry, my character is going to inherit from subject. Now, can I compile my character, or is it unhappy? Oh, it's quite mad. Marked override, but does not override. Well, that's odd. Oh, it would help if I included a subject. .cpp. There we go. Okay. I was unhappy because I didn't know what a subject was. I was very confused. All right, so that seems fine. Subject is fine. How is my game observer? Forgot to include observer. That would help. Let's try that again. Okay. Seems like everybody's happy for the moment. Now, a player. I mean, I suppose I don't really need to. Oh, here's what we'll do: is we'll add a method to player, which is going to be called void state change. And when this happens, we will call notify observers. And remember, from our so a player is a character is a subject, and a subject has notify observers. And we're going to notify observers by passing in a message and say player state change. And in my main function, we'll drop all this stuff because we don't really need that right now. PL dot notify observers. Or sorry, no, it's not notify observers. It's state change. Compile main. Redefinition of class observer, which means I need to put some include guards over there. Observer, and if, let's try that again, okay, and go. Oh, okay, nothing happened, that's not good. I think the reason for that is there are no observers that I notified, so I need to actually add some. So in my main function, right now nobody's looking at the player, so I need to actually give it something to look at it. So let's make some stuff to observe it. There is a add observer function, so let's do pl.add observer, and we'll make a new game observer, which also means I need to include game observer. And we'll do this, let's say we do it 3 times for fun. And now we can see that each of my 3 game observers was notified of the message. And now what I've done here is obviously not very impressive. I printed 3 lines of text, right? But what's more important about this is kind of the structure that I've built that connects all the different parts of my code together. So to reiterate the things that I've assembled now is all of my characters are considered subjects, which are game entities, but there's special kinds of game entities which, in addition to having the normal stuff that they would have, also have this observer functionality. And this functionality means that I can take anything, any character I want people to be watching, and I can staple on as many things to it to look at it and keep track of what's going on with it. Maybe it's location changes or something like that. And when things change, the ability for me to handle those changes is actually now very, very modular. If state changes, I call a function called notify observers. Right now, my state change is not very impressive. I'm just telling them, hey, the state has changed. But maybe I'll notify them with other things, and I will say, oh, notify observers, health has gone up, or notify them with something else. And now, in my notify observers, the code is very short. For each observer, notify it and give it a message. Maybe you give it something other than a message if you want to. It doesn't really matter. The important thing is that everything that cares about the state of the player or the character now can do whatever it wants to appropriately. In this case, we only made 1 observer. It's a very simple one. It prints out the message. But you can imagine other observers might do things like, oh, if the player has changed location, change the scene, maybe modify all the graphics around it, maybe do some animation or something like that. And so now I also can have any different kind of observer inherit all of the functionality of notifying. And any time that I want to add a new observer to my character, to my subject, it doesn't matter what kind of observer it is, as long as it's an observer. I can make, ABC observer, and it will still work okay without me having to modify my subject code, because my subject code works regardless of what kind of observer you are. All right, so that seems good enough for now. Let's move on to the next one. Okay. Develop an abstract state class with virtual methods like enter, execute, and exit. Create specific state classes like idle state, attack state, and move state, which implement these different virtual methods. For instance, when you execute move state, it should print makes a move. Okay, sure. So let's do that. It shouldn't be too hard. Again, close everything so I don't edit stuff by mistake. Copy exercise 6 to exercise 7. Oops. Okay, so we need a abstract state class with some virtual methods. Well, we already have a abstract game entity class, so we're going to duplicate it, and we're going to call this one state. Copy our instructions so we don't have to reference them over and over. And I think for the sake of a bit of laziness, actually, I'm going to make all of the state subclasses in here. You can, again, have them in separate files like I've done with everything else. And although it is nice to also have these separate files so I don't have to change all of them all the time, it does get a little bit messy having a million things in this folder, so it might be worth putting into the subfolders, which is something I think is a good thing to practice with. Okay, anyway, these are not the virtual methods I want. My virtual methods should be things like enter, execute, and exit. Okay, so enter, execute, exit. Cool. Okay. So now that I have made a virtual state class, not very impressive, I want to make the inherited classes. So idle state inherits from state. And it's going to void, public void enter. And I think we're just going to have these all print things when stuff happens to make it simple. IO stream. And we'll print, entering idle state. And we'll do this for basically everything. So entering idle state, execute will be idling, and exit will be exiting idle state. And now I can save myself some more time by just copying this twice. Copy, copy. And we're going to do attack state. What was the other one? Move state. Sure. Attack state. Making an attack. Exiting attack state. Entering move state. Moving. Exiting move state. And now what I have is a class that represents the state, the thing that that something is doing. I guess that's actually all it says, right? It just says make this state class. So that's good enough for me. I imagine this has to compile. It doesn't seem very complicated. -C. Yeah. But the whole point of this is that sometimes the state, the property, the being, the current activity perhaps, of a game entity or any other entity isn't best represented with a number or a Boolean flag. Sometimes it's best represented with one of these classes. And I can say, for instance, my player is in the attack state, and I can give it a member variable that is a state. And the state could be an idle state, it could be attack state, it could be a move state, kind of depends on what I want it to be doing. But the nice thing is, when these states change, this might be a perfect time to notify those observers. And I think that's what we're going to see in the next exercise. But for now, all I want to be able to do is very quickly make an abstract state class that has different properties for going into a state, doing the thing in the state, and then leaving it, which I have represented with these things here. So we're almost there. One more exercise, and then we'll call it up. Okay, so our last exercise. Modify the game entity class to use instances of the state classes. Then modify the main loop to enable entities to change states. Okay, so we'll do this a bit at a time. So let's first off copy exercise 7, exercise 8. We're almost done. Okay, and here is my instructions. Okay, so each game entity has these things, but it's also going to need to include state.cpp. State.cpp. and it's going to have a state. We'll call state. Not very exciting. Do I want it to actually be a pointer? Yeah, I probably want it to be a pointer. And we'll call this the current state. Just for a little bit of like precision so we can be more specific about this. So, and now what we can do, okay, so now our game entity uses instances of the state class. And I think what we'll want to do is when we, right now when we update, everything just prints out stuff, right? But I think what we want to do is we want to have it so that when we update, we're actually going to use this state. And we'll do that specifically for characters. I don't think we'll do it for other stuff. But let's say that we do it for a character. Sure. So when a character updates, instead of printing character updated, we'll say current state dot arrow execute. I think this should be okay. So now we have a state. We're going to need to obviously give it a state. So maybe it's the case that when we construct a game entity, we need to give it a initial state, current state, initial state. And then we update, when we do an update of a character, we won't do it for items. Maybe we'll just do the characters, and if you want to implement this for items, you can. But when we update a character, we're just going to run the current state, whatever that happens to be. And it says modify the main loop to enable entities to change states. So we're going to just do this for a character, and you can work out the logic to implement this for other things. But let's snag this, because this is what we're doing. Enable entities to change states. So we got a whole bunch of stuff in here. We did this for player. So maybe we'll leave the stuff in for player, and we'll modify this so that as the state change happens, we will notify everybody in the proper way. So okay, in that case, we have the character executing the current state, but maybe we'll actually do this for player instead. Players are a thing that we're actually doing this stuff with. Okay. All right. So when our player updates, we will execute the current state. When we do a state change, we're going to want to modify the state. Let's get rid of a bunch of all this other stuff because we don't really need this to be here. We just want our player. Okay, now, I got my player. It's got 3 observers, just to triple the messages, I suppose. Now, if I do pl.update, let's actually see what happens if I run all this right now. I'm not quite done doing what I want to do, but I just want to see what the current state of affairs is. Pardon the pun. G++ main.cpp. Okay, stuff is angry. What did I mess up? Use of deleted function player. Right, because I'm trying to create a player without having given it a state, which I need to. And now, something I also need to realize is that my player doesn't have a constructor, and neither does the character. So let's make a constructor for my player. And it's going to need to take a initial state as well. And we're going to want to call the game I suppose we'll keep this simple and we'll just say current state equals initial state. This should work, but I suppose we'll find out. And we will give this a new Don't forget to include states. How about we give it a new idle state? Still pretty mad. Why is it mad? It's mad because my character does not have a constructor. So let's do that. The thing is actually really quite angry because of all of the constructors that I'm missing. Subject. What are all the things it doesn't like? Game entity, subject, and character don't have empty constructors. So game entity, game entity, character, and subject. Okay. Just giving them some default constructors. I probably shouldn't be doing that. I actually should be like making this a little more modular, but I kind of just want to get rid of some of these things. Why are they mad? Undefined reference to character in here. Well, I certainly have my constructor, which doesn't seem very happy about it. What I think I'll do is I'm going to make, maybe what I'll do is I'll get rid of this constructor for now. Oh, I know what it is. It's this should have braces. Oops, wrong file. This is also supposed to have braces. Braces. And this can go back to I think where it was and should be okay now. Game entity also should have braces. There we are. Okay. Apologies for the corrections. So all of my constructors now are working properly. And then this one is going to set the current state to be the initial state. Okay, so now I can give my player an idle state. I will update and then I'll do a state change. And we'll see what happens when I do this. So idling right now. I should put some new line characters in my state so I can read this properly. So /n/n/n new lines, just to read this a little better. Compile, go again. Okay, so now I'm idling, and right now I just have a generic player state has changed notification. Not super exciting. So let's make it so we can actually change the state of the player. There's a few different ways that we can do this, and I think what I want to do though is I want to make something as modular as I can, which means that I want to make this state change accept a new state. We'll call this new state. And what we will do is current state exit, and then current state equals new state arrow enter, because I'm entering the new state, and then I will notify my observers that the state has changed. And in my main function, I will do another update. Now, let's run this and see what happens. Oops, missing the call for player state change, because I need to give it a new state. We'll give it a new move state. Now, something to be mindful of, and something that I haven't corrected here, which you definitely will want to, is right now I have not really handled the deletion of these things. So I'm making a lot of these new objects. I'm not deleting them when I change the state. This can lead to problems if you end up doing this at a larger scale. So just be very careful about declaring these ones inline without actually doing the deletion. But that's something that you can work on, I think, maybe outside of the video. But for now, I just want to run it and say go. And what happens? I'm idling. I exit the idle state. I enter the move state. I notify my observers. And now I am moving. And then again, the really nice modular thing about this is I didn't have to add a lot of code for that. I just said I'm exiting the current state, I'm entering a new one, so here is the entering, and I tell everybody, hey, I've changed my state in case you care about this kind of thing. Maybe you want to animate my arms differently because I'm moving instead of sitting there. But the ability to sort of take what is here now and modify it to work at a bigger scale really sets the foundation for being able to build in a lot of these bigger programs. And it's really the key, I think, point behind object-oriented programming, and specifically the topics of here, these abstract classes, is so that I have this behavior that I want to model for all of my different entities. I want to be able to have things that can observe. I want to be able to have things that are observed, things that are observing, and things that are observed. The observers being the observing things, the subjects being what's being looked at. And now anything can be anything that is a game entity, I can have be a subject, and these subjects are going to have this whole observer functionality. I also could have something that's not a subject. So if you look back, my items are still just game entities that are not subjects. They're what happens to them is not observed by anybody. But I could modify that if I wanted to. Maybe I want an item to be a subject, and all I have to do is make the appropriate changes. And this is entirely dependent on what you're building. But I think this video is long enough as it is. I think it's a good place to wrap up. And so really a lot of the things that we've covered here are really all about understanding how these virtual functions work together, how to make abstract classes, how to inherit from them, implement these functionalities, and really in particular the second half of this was a lot about being able to apply these specific behaviors, the idea of observing, of being observed, are just sort of general patterns that we want to apply to existing objects without us having to manually put this kind of stuff in every single object that we have. Instead, I can just say, hey, a player is a character and a character is a subject, so it can do all this observing stuff. And if I don't want it to be something like that, I can just change what it inherits from, and then I don't have to do so. Okay, that's it. Thanks for watching, and I'll see you in the next video. Bye-bye.